Hello everyone, this is grade 6, module 2, lesson 17, problem set. Now, for this lesson problem set, we're going to be seeing if numbers are divisible by other numbers. So, in the lesson summary, we have our statements for if a number is divisible by 3 and 9, and I also brought in the divisibility rules for 2, 4, 5, 8, and 10 from the discussion earlier. So we have all those to refer back to. So let's take a look at one. Is 32,643 divisible by both 3 and 9? Why or why not? So let's take a look first at how we figure out if it's divisible by 3. So we have to find the sum of the digits and see if it's divisible by 3. The same is going to be the case for 9. Find the sum of the digits and see if it's divisible by 9. What that means is I'm going to take 3, 2, 6, 4, and 3. So 32,643, and take those as individual digits and add those up. 3 plus 2 is 5, plus 6 is 11, plus 4 is 15, plus 3 is 18. So, can 3 go into 18? Yes. Can 9 go into 18? Yes. 3 times 3 times 6 is 18, and 9 times 2 is 18. So they're both, that number is divisible by both 3 and 9 because the sum of the digits is 18. Let's take a look at 2. Circle all the factors of 424,380 from the list below. So we got to look at 2, 3, 4, 5, 8, 9, and 10. For this, we're gonna check all of them. So 2. If we look up at the top, divisibility rule for 2, if and only if its last digit is 0, 2, 4, 6, or 8. Well, let's look at the last digit. It's 0, so 2 is it's divisible by 2. 3, we know we have to add these up, so we can do 3 and 9 at the same time. So 4 plus 2 is 6, plus 4 is 10, plus 3 is 13, plus 8 is 21, plus 0 is 21. So now we have to look at it and see, can 3 go into 21? Yep, 3 times 7 is 21. But 9 can't go into 21 because 9 times 2 is 18, which we did up above. 9 times 3 is 27. So I'm going to put an X through 9 just so I know not to check that again. Okay, let's check 4. Divisibility rule for 4 is up above. It says, if and only if its last 2 digits are a number divisible by 4. So the last 2 digits are 80. And we know that is going to definitely be the case that 4 can go into it. It can go into it 20 times. So 4 is good. 5 says, if and only if its last digit is 0 or 5. We know that the last digit is 0, so it's definitely going to be 5 as well. Let's look at 8. 8 says, if and only if its last 3 digits are a number divisible by 8. So last 3 digits is 380. So we got to see if 8 can go into that. That'll be 32, 6. And I know this isn't going to come out even. I'm going to have to make it a decimal. So 8 is not. And then for 10 it says, if and only if its last digit is 0. And we know that the last digit is 0, so it should be 10 as well. So that's all we're really doing is looking at these divisibility rules and seeing if they apply to it. So for 3, we have the same thing. I'll do it down below. We have 322,875. For 2, it doesn't end in 0, 2, 4, 6, or 8. So 2 is not divisible. Let's add these digits up. 3 plus 2 is 5, plus 2 is 7. Plus 8 is 15, plus 7 is 22, plus 5 is 27. 3 can go into 27 9 times. 3 times 9 is 27, which means 9 can go into it because it goes in 3 times. So we knocked off 3 and 9 right there. 4. 4 is the divisibility rule where the last two digits. So we got to look at the last two digits. And that's 75. Let's divide that by 4. And that's not going to be the case. So 4 is no good. 5, it has to end in 0 or 5, and it does. 8, we have to look at the last 3 digits. So we have 875. We're going to divide it by 8. 7. And now we have to see, does 8 times anything give us 75? 8 times 9 is 72. With 3 left over. So that's no good. So 8's no good again. And for 10, the last digit has to be 0, and we can see that it's 5. It's not 0. So we should have 3, 5, and 9. 4 says, write a 3-digit number that is divisible by both 3 and 4. Explain how you know this number is divisible by 3 and 4. Well, I know for 3 I have to be able to add the digits up, and it has to be divisible by 3. And so it has to be a multiple of 3. And 4, the last 2 have to be divisible. So what I'm going to do is select, my last 2 digits are going to be 12, because I know 4 can go into 12 3 times. Now, if I add 12 up, 1 and 2, I get 3. So right now it's divisible by 3 as well. But I have to add another digit, and I have to put it in the hundreds place. So I just have to add something that's a multiple of 3. So I'm just going to put a 3 out there. So the last 2 digits is 12, so it's divisible by 4. And then if I add all of those up, 3 plus 1 is 4, plus 2 is 6. 6 is divisible by 3. So I would then write my explanation in there. But I'm not going to because I just said it out loud to you. But that works. So just make sure you get yours written in there. And let's take a look at 5. 5 says, write a 4-digit number that is divisible by both 5 and 9. And then explain how you know that this number is divisible by 5 and 9. So our rules for 5 and 9. For 5, has to end in 0 or 5. And then for 9, we have to add it up, and it has to be a multiple of 9, meaning 9 has to be able to go into it. So I'm going to end my number in 0. That immediately means that 5 can go into that. And now what I have to do is get 3 other spots that add up to a multiple of 9. So I'm going to put, let's say, a 6, and then 2. So 6 plus 2 is 8. I need something to get me to a multiple of 9, and I'll do 1. So 1,260, the reason is because it ends in 0, so 5 can go into it, and when I add these up, 1 plus 2 is 3, 3 plus 6 is 9, 9 goes into 9 one time. So that number right there is divisible by both 5 and 9. And some other numbers, but we're looking for just 5 and 9 right now. Hope this helps. Thanks for watching, and good luck on the rest of your problem set.